Now, we will consult ACI 530-13, the building code requirements and specifications for masonry structures. You may notice that the entirety of these checks depend heavily on the masonry compressive strength, F'M. We will take F'M as 1.5 megapascals. This is based on research for river rock stone masonry in running bond and is adjusted based on hand-mixed mortar in the field. So this research is presented later in the unit if you're interested, and we'll just use this value to define our various stresses and capacities. And in order to find our applicable equations, we need to start with the h/r ratio of the section. H is going to be our wall height, which we can take as the back wall to centerline value from the drawings. R is a radius of gyration. Radius of gyration for a rectangular section is the depth over square root of 12. And the depth of our wall, D, is taken as the distance from the top of the back wall to the bottom of the anchor, where the max force transfer occurs. So I've drawn all these things out for you in addition to our moment of inertia, I, and our section modulus, S, which we'll discuss a little bit more later on, but I've summarized all of the equations for both the X, over the X and over the Y axis, the strong axis and the weak axis, so that we can perform checks for both axes, and we'll always take the axis that governs. So, for example, a 10-meter long abutment that is 3 meters tall from the bottom of the anchor to the top of back wall has an h/r ratio of about 11.5. And next, we're going to check check the bearing stresses for adequacy. This will be a quick check, and it's referring to the bearing surfaces, the anchor to masonry and masonry to masonry, or rather concrete to masonry and masonry to masonry bearing. Using our engineering judgment, we can determine that the masonry portion will govern the bearing stress check. And here is a quick plan view showing you what it looks like, what the bearing surface looks like, that minimum 30 centimeters as defined by the drawings and the field operations binder. So section 8.1.5 of ACI 530 gives us the simple ultimatum that the allowable bearing stresses FB shall not exceed 0.33 F'M, which is going to be equal to not 1.5, but 0.5 megapascals, if I were taking our F'M as 1.5. And this should be computed over ABR, which is the bearing area. Section 4.3.4 further explains bearing area, but it allows us again to increase the bearing area at a 2-to-1 slope from the point of the load, but is limited by the following conditions. A2, it's limited as a maximum of A2 times the square root of A2 over A1, or 2A1. And we can quickly notice that 2A1 is the governing condition, and A1 is the area of, where A1 is the area of the anchor touching the ramp wall, or the loaded area. Therefore, the bearing stress can be computed as P wall over 2A1. And I've drawn a few diagrams here for you just showing that A1 and A2 and how it's the allowable increase in area as forces are distributed across a large area of wall. And we'll finally make our check that capital F'B or capital FB is greater than 1.5 P wall over 2 A1, which is going to be our A1 is going to be our anchor beam width times the length of the inclined face. And not the anchor beam width, but it's the anchor beam width touching the masonry wall. And in this case, it's always going to be, for standard drawings, 30 centimeters because we have a minimum of 30 centimeters of bearing onto the masonry walls. So we want to be evaluating this for our worst case scenario.